Hey everybody, hope you're doing well. In this video I want to talk about the constant multiplier rule, the power rule, and the sum and difference rules for differentiation. So, let me start off by an example, and then I will talk about all the rules that I just used. So suppose I have a function that is 3x squared plus 4x plus 8. Now, the derivative of this, we're going to denote it by f prime of x, is 6x plus 4. Now, so what rules did I use? Okay, so the first thing I notice is that I have a 3x squared, a 4x, and an 8. And in between those, I have plus signs. So each time I have a plus sign, I am going to use the sum rule. And the sum rule basically says that if I have two functions and I add them together, the derivative of that sum is the individual derivatives of each term. And so what I can do is decompose this problem. Instead of one big problem, I'm going to decompose this into 3 smaller problems using the sum rule. So how do I take the derivative of each one of these? Well, each one of these is a different type of a rule. So what about 3x squared? I have 3. I'm actually multiplying it by x squared. So in order to do this, I'm going to invoke something called the constant multiplier rule. I'm going to just abbreviate it with a CM. So what is the constant multiplier rule? Well, it basically says that if I have a constant, and if I want to multiply it by a function, and then take the derivative of this thing, I can leave the constant alone, and then multiply it by the derivative of that function. So in order to take the derivative of this, well, the 3 is going to come along for the ride. In other words, I'm not going to do anything to it. But I need to know how to take the derivative of x squared. So the derivative of x squared, this is something called the power rule. X to a power. Well, here's the general power rule. If I have a function raised to the nth power, an x raised to the nth power, and I take the derivative of it, I'm going to drop the power, leave the base alone, and subtract 1 from the power. So I can use these rules to figure out the derivative of 3x squared. So the derivative of x squared, according to this, if n is equal to 2, is 2 times x to the, 2 minus first power, which is 1. So the derivative of this, and I'm just going to put a little d on there, the 3 is going to come along for the ride. I'm going to drop the power of 2, and I'm going to subtract 1 from the exponent. A lot of times I don't like to write down 1 as an exponent because it looks like a prime. So I will rewrite this as 6x. Now remember, the operation in between this is multiplication. So the derivative of 4x, again, 4 is going to come along for the ride. I'm going to drop the power. Remember, x by itself is really x to the first power times x to the 0th power. Now, do you remember what x to the 0th power was? Well, that's just 1. So this becomes just a 4. Now, what about this one? How can I apply the power rule to this? I don't even see an x. But what I can do is I am going to write 8 as 8 times x to the 0th power. If I take the derivative of that, 8 is going to come along for the ride. I'm going to multiply it by drop the power, which is a 0, and then x to the negative 1. 0 minus 1 is negative 1. 8 times 0, that's just 0. So that's how I got each one of these pieces. I didn't put a plus 0 on there, because we normally don't. So this is a combination of the sum rule that decomposed it into 3 problems, the constant multiplier rule, That's where the 3 and the 4 and the 8 comes along for the ride. And then the power rule is while dealing with exponents. So let's do one other problem. One more. So I'm going to make this function just a little bit harder. I want to take the derivative of this. Well, what I would like to do before I take derivatives, I'm going to do a little algebra housekeeping here. I'm going to rewrite this as 3 times x to the 1/2 power. Now I have an exponent, so power rule is coming into mind. 5 times x to the negative 1/2 power. So just remember, square roots are associated with half powers. That's the rule that I'm using here. This is not a power rule. I haven't done any calculus yet. So I'm going to apply my constant multiplier rule, my sum rule, and my power rule to this particular function. So the first thing I need to do is I'm going to decompose this problem up into pieces. I have a 3x squared, a 3 to x to the 1/2 power plus 5x to the negative 1/2 power. So let's deal with this one first. 3x to the 1/2. Now when I take a derivative of this, 3 is going to come along for the ride. I'm going to take the original exponent, make it as a coefficient, leave the x alone, and I'm going to subtract 1 from the power. 1/2 minus 1 is negative 1/2. So I can simplify this a little bit. 3/2 x to the negative 1/2 power. Now let's try the 5x to the negative 1/2 power. Let's try this one. Let's take a derivative. 5 is going to come along for the ride. I'm going to drop the negative 1/2, leave the x alone again, and then subtract 1 from the power. Negative 1/2 minus 1, well, that's negative 3/2. So I'm going to neaten this up a little bit. I'm going to put the minus out front. Whoops, 5, my bad. X to the negative 3/2 power. You could leave it like this, but I'm going to take this one step further. I could rewrite it like this. 3 over 2 root x minus 5 over 2 root x cubed. So if I start with symbolic notation, I'm going to convert it to power notation or exponent notation, and then at the very end, I'm going to put it back into symbolic notation. So here are two examples that uses the constant multiplier rule, the sum rule, and the power rule. I hope this was helpful. Have a good day. If you have questions, let me know.